love Jaden trying to come. That's you.
So sincere.
You left me.
Okay, are we done? Okay. Most of this chapter is going to focus on quadrilaterals, but the first section is actually going to be on all types of polygons. Okay, so some of this will be review. Remember what a polygon is. We have to have all the sides. They have to be straight, has to be closed. Here's a polygon. What makes it not a polygon? What can't we have? Yeah, we can't have like a curved line. We can't have like, something that's not closed. Okay. Okay, convex versus concave. We also remember how to distinguish between the two? Yeah, concave goes inward at some point. Basically, convex, the way we describe it, you don't really need to know these definitions. Yeah, so if I were to extend each of the sides in this one, none of the sides go through the figure. But if I extend the two sides here and here, they end up crossing. So I like to just think it caves in at some point. Okay. What we're going to look at now are the sum of the interior angles. So interior meaning inside. Okay. So what's going to happen is the more sides we have, the bigger the sum. So triangle we all know, or should remember. How many degrees does a triangle equal?
180.
180. So all the angles in a triangle have to add up to 180. Okay, now we get a quadrilateral. So what we're going to do is we're going to extend just one diagonal from one vertex. And how many triangles do we create? Two. So it would be 360 because each of these would be 180. So that'll be 360 total. All right. Pentagon, how many triangles? We end up 3. 3 times 180. Close.
530.
A little bit more.
560.
540.
Whew.
That was close.
Okay. Hence the reason I asked you to have a calculator.
720.
Wow. 720. Look at that mental math. Okay, that was probably the easier one. Okay. So you imagine if you had a polygon with 100 sides, 100 times 360, or sorry, 100 times 180. So, right, you have, now obviously we're not going to look at polygons with 100 sides. What's that? Go back. Now, you do not need to memorize all of these numbers, okay? We have not done this specifically, but we did do the names of the polygons. So hopefully we still remember them. If you don't, make sure to go back and review them. Yes. Okay, so triangle, 3 sides. We said sum of the angle measures is 180. You do not need to know these two, like you don't have to memorize this part. Okay?
But the number of triangles.
But you need to, so if I say, what's the sum of the interior angles of a nonagon, you need to remember that that's 9 sides. You don't need to have this memorized, but there are other things we have to memorize.
7 triangles.
Yes. So if we had a quadrilateral, so if we look on that previous page, we had 2 triangles. So 2 times 180, we said was 360. When we had a pentagon, how many triangles did we have? 3. So we had 3 times 180, which gives us 540. Okay, we didn't do hexagon, but if you had to guess, how many triangles would be formed from a hexagon? 4. So, oh no, we did do a hexagon. I'm sorry. We didn't do the next one. So we said 720. How many triangles in a heptagon? 5. Okay. Do we? Okay. So now we could keep going. Blah, 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 blah. We want to look at a formula for any number of sides. So if we have n sides, how many triangles do we have?
Those have to be over 12 or 13, so you can say like 16 sides.
Yeah. So what I'm saying is like this would represent any number of sides. So it could be more than 12. But it could say n. Okay, so we would just say n gon, right? Like 16 and then GON. That's what we would write. So if there are n number of sides, how many triangles would we have?
No, n over 3.
Okay, let's look at the pattern. If we had 3, we had 1 triangle. If there are 4 sides, 2 triangles. 5 sides, 3. How many are we subtracting each time? N minus 2. So our formula is going to be n minus 2 times 180 degrees. And here is our interior angle sum theorem. So S represents the sum. N is the number of sides. So if I now ask you, in our first example here, find the sums of the measures of the interior angles of each convex polygon. So this has to be a convex polygon. It doesn't work for concave, so keep that in mind. Okay, so
2,520.
yeah, we're going to do 16 minus 2 times 180. So 14 times 180. 2,520. Okay. Now we have something that's not an exact number. This is 8x GON. So that could be 8 times 10. It could be 8 times 12. We don't know what x is. How would we write that sum? 8x minus 2 times 180. So what can we do? We can distribute. So we're going to do 8x times 180. 1,440x minus 360. So we would just leave our answer like that. Good. Okay, we want to find the measures of each interior angle. There's a quadrilateral. So how much does a quadrilateral add up to? 360. Some of them are worth memorizing. So I would say at least the ones that the first ones up to hexagon would benefit you to memorize because they show up a lot. The other ones I wouldn't necessarily memorize. You just need to know the formula. So we know x plus 2x plus 2x. Okay, what do we get when we combine all the x's? Yeah, I think these numbers come out nicely. So x equals 60. So that means A and D are both 60. And B and C would both be 120. And then you could check your answers by just adding all the angles and just making sure it adds up to 360, but that one was easy enough. Good? Questions? Okay, how many sides does this one have? 6 sides. So if we're not sure, so our sum would be 6 minus 2 times 180. And that would be 720. Okay, so again, the more sides we have, the larger the sum is going to have to equal. Here, I have 2 angles that are 2x, and I have 4 angles that are 9x plus 30. So let's see, we get 4x plus 36x. What do we get? 40x equals
Equals 600.
600. That's going to give us 15. All right. Well, J and M are easy, so that would just be 2 times 15, so 30 degrees. Here and here. And what do we get when we plug 9 times 15 plus 30?
165.
Good, so these are just all.
So that's how you just solve it easy, just multiply it.
Yeah, so basically if I had a pentagon and I had a whole bunch of different angles, how are you going to find the sum? You would add them all together and set it equal to 540, right?
But 540, wow.
Well, because 5 minus 2 is 3. 3 times 180 is 540. Okay, quick review. Regular polygon. How do we know a regular polygon? It's got to be convex. All the sides are congruent. All the angles are congruent. We call that equilateral and equiangular. Okay, so let's say I wanted to find just one. Here we have a regular pentagon. So what did we say the sum of the angles in a pentagon? We said it was 540. So if I wanted to find one interior angle, how would you find that?
Divided by 5.
Yeah, I divide it by how many angles are there? There are 5. So what would we get for one interior angle?
108.
108. So that means every angle here, right, would be 108. Makes sense, right? If they're all the same, we just divide. So we could expand this into the measure of one interior angle of any polygon is going to equal what? What did we have in the numerator?
540.
Okay, but what did that represent?
Sum.
The sum. What's the sum?
540.
No. In general terms.
Everything ended
What
up
was the
being
formula that we used? N minus 2 times 180 divided by the number of angles, which is the same as the number of sides. So divide by n. So if I asked you for one interior angle of any regular polygon, we would use this formula. So this is where I was saying there are a couple things that you might want to make flashcards. This is one of them. Okay.
Sorry.
Is it really though?
I think my brain is.
Is it really though?
It seems
Come on, we got
Is
this.
that 160 or 180?
Oh, that's 180.
I'm not even keeping track.
Okay, we're gonna be.
Because I know the bottom
I can
is for the
figure this
angles, right?
No, so n is the number of, n equals the number of sides,
Oh wait, would you just do 155 minus 2 times 180?
but it would also be the number of angles. Okay, generally we say n represents the number of sides, but if there are 5 sides, there's going to be 5 angles. If there's 6 sides, there's going to be 6 angles. So you could think of it as one or the other. Okay. All right. So the measure of an interior angle is given. So this is one interior angle. We want to work backwards and we want to find the number of sides. So we want to figure out what n is equal to. What would we do?
135 times 2.
Well, no. We're trying. N is not 135. N is what.
It says regular polygon has 5 sides.
Okay, so basically I'm giving you the measure of an interior angle of some regular polygon. But I don't know how many sides it has. I don't know if it has 8 sides, 10 sides, 13 sides. That's what I'm trying to find. So I want to set 135 equal to that formula. Okay? Okay. Ideas here. How could we solve this?
Multiply everything by n.
You can multiply both sides by n. You could also think of putting 135 over 1 and cross multiplying. So I get 135n equals
N minus 2.
times 180. Okay, now how do we go to solve? Now it's just algebra from here. Distribute. So I have 180n minus 360.
Subtract 180.
Okay, so that'll be negative. What's 135 minus 180? So negative 45n. Yeah. Then divide. N equals 8.
Sure.
Yeah.
Sure. Always make sure you get a positive answer here. A negative wouldn't make sense. You can't have negative 8 sides, so just make sure. Okay.
Oh, so that means there are 8 sides.
So that means, if I said, now if I ask you how many degrees does each interior angle in a regular regular octagon equal? 135 degrees.
Times.
Well, no, we found out 135 would be the angle measure for all the angles inside of an 8-sided polygon. That 8-sided polygon is called octagon. Okay, now we have an even bigger angle, 156. This should be easy. Well, we're going to set it up exactly the same.
Oh, it's always just going to be 180 and
It's always going to be 180 minus 360. 180 and
just leave it that way, sort of.
I mean, I guess if you want to, you can skip a step.
Sure.
Okay, 156 minus 180.
24. Negative 24.
Okay, so when we divide,
15.
Wait, I don't really understand how you get how you get the 360.
to distribute.
180 times 2. Gotcha.
Okay, good. All right. What's
Oh no, I flipped to the wrong side.
This is the last page. We're already on the last page. We got this.
Why is it cultural tree that's still big trees in algebra?
Shapes.
It's algebra trees.
Last page. Exterior angles. What are exterior angles? So they're on the outside. Woo! Okay, let's take a look at some examples. I'm going to just look at specific examples of regular polygons to make it easy, and then we'll extend it. Okay, so I'm going to extend each side. So I'm going to extend that side. I'm going to go, and you can only have one exterior angle at each vertex. So, and then I'm going to extend it this way. Okay. So we got these nice little arrows, pictures. Okay. So I'm using examples of regular polygons. This would be an equilateral triangle. What are each angle in there?
60.
60. So 60, 60, and 60. So let's take a look at each exterior angle. So the one at the top, if this is 60, what's the one exterior?
120.
120. They have to make a linear pair. 120. This one down here.
20.
Same thing. 120. What's that?
It didn't say it's equal.
Yeah, where I highlighted. So I said using regular polygons as examples, we're going to draw the exterior angles at each vertex by extending one side. Okay, what do we notice about the sum of the exterior angles?
Oh, they all equal 360.
So 3 times 120,
Yeah.
I end up with 360. Okay. Let's see what happens if I add an extra side. So now I have a square. So I'm going to extend each side. Okay, now if these are all 90 degrees, what are all the exterior angles?
110.
What?
Wait, I meant
What?
9.
It's okay. Should I cut that from the screencast or
Yeah,
we'll just leave it? Okay, got it. Okay. So 90, 90, and 90.
Thinking of 200. When I missed today, I did 6.
Yeah, I don't know.
You mostly hear my voice, but sometimes you can pick up.
You can hear.
Yeah.
You can hear
Hi, Jaden. Hi, Misa.
Yeah, you can hear
and
like
you
the
never hear
beginning.
anyone else. This is a very dangerous shape.
Okay, what?
What?
A hexagon?
It's not like. Okay.
All right. So I'm gonna. So this is gonna be extending one side,
Why not?
each vertex. Makes a fun little picture here.
Spider.
Okay. It's fine. It's fine. We'll go with it.
Spiders have 8 legs.
I'll save you some time. Each interior angle of a hexagon is 120. Okay.
Oh, wait.
Centipede.
Okay. Okay. If each interior angle is 120, what is each exterior angle? 60. And how many of them do we have? 6, because it's a hexagon. So if I do 6. Ah.
Yay!
Yay. Okay. So it doesn't matter how many sides we have. They're always going to add up to 360.
I'm not good at this.
If you want to think of it almost like if when we draw the arrows, it like goes around in a circle. Think around the circle is 360. So the exterior angle sum is the sum of the measures of the exterior angles is 360. Oh, let's see. Okay. Now, what if I want to just find one exterior angle of a regular polygon? So, okay, what was the sum? The sum was 360. And I want to divide it by the number of angles or sides, which would be n. Now, just a quick note. What did we notice about the interior angle and exterior angle? What do they always have to add up to? 180. So just a reminder, these are forming a linear pair. So an interior angle plus an exterior angle always equals 180. Okay, so now I want to do 2 things. I want to find the measure of an exterior angle and an interior angle for each regular polygon. Okay, so if it's a pentagon, this means n equals 5.
Isn't it easier to do like the exterior first? Yeah.
100%.
It's a linear pair.
Okay, so do I want to do the interior angle n minus 2 times 180 divided by n? That's a more complicated formula. It's so much easier to find the exterior angle first.
Oh, I found the interior.
Because this we would just have to do 360 divided by 5.
Never mind.
Never mind.
I found
We
the
get
exterior.
what's 360 divided by 5?
72.
72. Which makes my interior angle, I can just do 180 minus 72,
108.
108. Now you could do the interior angle formula if you wanted to double check, but this is fine. How about dodecagon? How many sides? 12 sides. So we have our exterior angle is 360 divided by 12. And that makes our interior angle 150. Okay, find the measures of an interior angle and an exterior angle given the number of sides. So these numbers here,
What would you just do?
this is n. I would probably do the same thing. So exterior angle I would do first. So 360 divided by 20 gives us 18. Good. It's just like yeah, exactly. So, and then the interior angle, 180 minus 18, 162. Okay, and the last one, our exterior angle. This does not come out nicely. So I mentioned we went around to answer to the nearest 10th place. Wait, what did you say? Oh, 25.7. We agree?
Did you think I said 27?
No, I just didn't hear. Okay, so the interior angle, 180 minus 25.7.
154. I didn't think you said
Wait, what did you say? 0.3? Yeah. What's wrong?